Let's discuss on the part 2.1, how to protect a resource endpoint. So it's just like in the continuation of the part 2, where we are trying to design a protected resource. So yeah, let's quickly jump discuss on this. This session will be a little long, but let's cover all these scenarios and section to understand more, and then we'll discuss the conclusion part later at the last. So let's quickly jump to the slide one. Yeah. So in continuation of the previous section, let's see how implementation of resource endpoint is built. Like for an example, let's check the protected resource.js. So this is our one of the JavaScript file for the protected resource where we are trying to put the logic of the API. So here we have the app.get hello world with the get access token function request result. So yeah, we are just putting the same thing like as we have seen in the previous section that we are just defining few languages, but if that language is not greeted by the user, it's not in the scope, then we are just going to give some error, correct? So here, yeah, so if request.access underscore token, in that, let's put the condition. So if the request query language equals to en, that is English, then what is the output? So result.send hello world. Same thing for the de in the else if, right, for Germany, right? So it will just greet the user in the Germany. So whatever the language we are supporting here, like the 5, so if the user is giving the greeting in that, so we are going to greet in that language. But if the user in the else condition, as we mentioned here, so if the language is invalid, so in that case we can just give some error, that is invalid language. Okay, so let's have a look on this. This is just an API we built, and we'll try to understand like from where the vulnerabilities can come and how we can make the practical implementation to stop that. So in this case, like we have the access token value. Scope value is a greeting, get OAuth token, and greeting these languages. So these are the basically the requirement, and access token with the greeting scope. So let's go to the next slide. So let's see example 1. So greeting in English. So this is the scope given by the end user, that is greeting in English. So in that case, how our program is going to work, how our API is going to work. So it will simply result hello world. True, as we have seen in the previous section. By clicking on the greeting button, you can request a greeting in English, which causes the client to call the protected resource and display the results. Okay, the basic logic, whatever we have seen, right, that we put in the protected resource.js file. So we're just trying to see the examples for that. So yeah, this is the greeting in English. So this is the result. Now let's see example 2, where the greeting is like invalid language. The language what we are supporting, the 5, it's not there, so it's an invalid language. So in that case, what is the error? It's the invalid language :fi. Okay. It is also possible to directly hit the resource endpoint passing an access token by using a command line HTTP client such as the curl. So that is also, maybe you already aware, some of you already know that using the curl also you can simply call that API by passing that access token. So there are two ways of passing an access token, as we understand from the previous sections, like from the common OAuth client vulnerabilities. So one thing, whatever, like in general what we are using, that as you can see in the first example, the curl space -v space -h, we are just passing the bearer token in the authorization, right? And then we have the API http localhost 9002 / hello world query language equals to en. Or else what we can just try draft the URL like curl space -v, because here we are passing the access token as a URI parameter, as we have seen, right? And there is a vulnerability in this section, so we need to avoid, but yeah, there is a way we can do it this way also. So http localhost :9002 / hello world query access token equals to token and language equal to en. So you can pass the access token in the URI parameter, or you can pass the access token in the authorization header form, as we are doing in the first this example, right? This one, the curl -v -h, we are just passing the bearer token in the authorization header, and then we are just calling the API. So there are two ways we know. Okay, let's go to the next one. So in both the cases, the result will be something like the following response. So the result definitely will be same if we are trying to greet in the English. So it will give the 200 okay, x powered by express, content type, text HTML, char set equals to UTF-8, that encoding, content length, date, connection, and then we have the result, that is hello world. In both, as you are going to pass the access token in the URI parameter, or you can pass the access token as authorization header, both option you have. But we know the problem in the URI parameter. Already we covered that in the common OAuth client vulnerabilities. So now let's try hitting the /hello world endpoint by passing an invalid language. So you say, let's say curl space -v, the URL http localhost 9002 /hello world with the query access token equal to token and language equals to fi. That's the invalid language we are putting. Now how the response is going to we are going to get? So same thing like as we have seen, but the result will be like invalid language. Correct? That the error message we can see. So far so good, but as any bug hunter will notice, it seems that the error response of slash hello world endpoint is designed in a way that the erroneous input bounces back into the response. Let's try like to understand this more, like by passing a nesty payload. So let's see here, like curl space hyphen v. Then you have the localhost address with the hello world query access token equals to token, and then language is equal to, you are putting some nesty payload. That means you are putting a script alert with the cross-site scripting accesses. You are just putting this value in the, as a script, right? Language equal to some script part. Now what is the output here we are going to get? Let's see in the next slide. So it will just give the same thing. The result is like error, invalid language, and the whatever the script you are putting, it's embedded here in the output. So what happened here, as you can see, the provided payload is returned verbatim and unsanitized. Correct. So at this point, sorry. So at this point, the suspicion that this endpoint is susceptible to cross-site scripting is more likely true. And the next step is pretty simple. In order to exploit this, an attacker would forge a malicious URI pointing to the protected resource. That means in that URI, attacker can just add some malicious URI. Let's see from example only. So this is the address, right? A localhost 902 hello world query access token equal to token, and language is equal to some script alert accesses something. So when the victim clicks on it, the attack is completed, forcing the JavaScript to execute. So in real scenario of attack, it would not contain a simple JavaScript alert, but would rather use some malicious code. Like for example, would extract data to allow the attacker to impersonate an authenticated user. So our endpoint is clearly vulnerable to XSS attack, so we need to fix it. At this point, the recommended approach is to properly escape all untrusted data. So we are using URL encoding here. So what we are trying to do here, URL encoding to prevent from this. But yeah, let's see that whether this is going to prevent the entire thing or not. We'll just need to understand more and more once we go little deeper. So here, let's see how our code is going to look. The same thing is, the code is just like the same, but in the invalid language, you can see how we are putting the output now. Query string dot skip in the bracket request dot query dot language. So what is this query string dot skip? This is basically refers to a method that used to encode a URI component by skipping special characters, so they can be safely included in the query string. And this is basically used in the older version. In modern JavaScript, if you can talk, people are using encode URI component method. That's the preferred method people are using to encode a URI component, right? By skipping the special character. So this is just like we are trying to encode, we are trying to include the encoding part here for the output of the invalid language result. Because when there is a valid, there is no issue, but in the case of invalid, we see the problem. So, and we need to tackle that. We need to just make some practical implementation to, to remove those vulnerability or to mitigate those vulnerability. So let's go to the next section. So after putting encoding, what happened, you can see what is the result now when you put the curl command. So it says HTTP 200 OK, X powered by Express, content type, content length, dead connection, and then we have the error invalid language, and then we see this modulus 3 script something, as the output, whatever we have, it's just giving me something with the encoding data. That's what we are trying to do. Now consequently, the browser will render the response without executing the ROG script. But here, are we done? But yeah, it's not quite, it's basically not quite yet, right? There are still the issues. So output sanitization is the preferred approach for defending against cross-site scripting, but is it the only one? Maybe no. So the problem with output sanitization is that developers often forget about it, and even if they forget to validate one single input field, we are back to square one in terms of the cross-site scripting production. So browser vendor try hard to stop XSS attack and ship a series of features as mitigation, and one of the most important being returning the right content type for the protected resource endpoint. So by definition, the content type entity header field indicates that the media type of the entity body sent to the receiver, or in the case of the head method, the media type that would have been sent at the request bin a get. So returning the proper content type might save a lot of headaches. Returning to our original unsanitized slash hello endpoint, let's see how we can improve the situation. So still the situation has not improved, right, by putting the encoding also. So now we need to see how we can make it like, how we can mitigate all those. What is the solution then? Right. So let's go to the next slide. So one second, let me go back. So yeah, so this is the previous result. Now in the next section, so here the content type is text HTML, what we have seen in the previous one. So this might explain why the browser happily executes the ROG JavaScript in the zone cross-site scripting attack. Now we can just try using some different content type. So previously what we have the content type, you can see, right, that content type is text HTML, as I have already highlighted here, if you can see, right. So now what we are trying to improve here, we are trying to use a different content type like application JSON. So in this, what we need to make a change in our code, like app.get hello world get access to, that will same where resource like greeting is there, and then we have this all the logic here for the condition with the request query language. But if it is an invalid language, then we have the request.query.language, and then we are just putting the result in the JSON form, result.json in the bracket resource. That means now you can see how the result is going to come for the invalid language. So in this case, let's say we are putting like curl space hyphen v, the URL, and in the query we are passing access token equal to token and language equal to en. We are passing access token in the query parameter only. So what this output will return? This will return like 200 OK, expert express, content type is now application JSON, char set UTF-8, content length, date, connection, and then we have the greeting as a hello world. So what you can see now, the result is coming in the JSON form. Earlier, if you can go back, how the result, just go back little, like it's just a text, right? Hello world. So now we have the result in the JSON form. Now if you just try with some invalid language like curl space hyphen v, the URL, access token language equal to like a script, that form. Now how is the output? So here we have the same, this format. Now the result is in the JSON, and what is the result? Greeting with the error invalid language, and then whatever the language equal to, it's just embedded in this output like a script alert something. So notice that in this case also the output string is not sanitized or encoded in any way, but it is now enclosed in a JSON string value. So if we try this straight in the browser, we can appreciate that having the proper content type immediately stop the attack on its own. So browser have that also the feature. So if we are just passing this in a JSON, it can stop the attack on its own. But in this case also the output is not sanitized. As we can see, right, the invalid language, the script part, whatever the, like in the URL API we are passing in the language, it's just embedding in the result also, but it is in the JSON form. So this happened because browser respect the contract associated with the application JSON content type and refuse to execute JavaScript if the returned resource is in this form. It is still entirely possible for a poorly written client application to inject the JSON output into an HTML page without escaping the string, which would lead to the execution of the malicious code. As we said, this is just a mitigation, and it is a good practice to always sanitize the output. We combine this now into the following. Let's see. So now let's see what we have, like what we're trying to do here. Like we're just trying to combine the encoding part and the JSON part. So app.get hello world get access token, this is a query. So if you can see the output part, so here we are just putting like resource.greeting equals to error invalid language plus query string to escape request query language. We are putting the encoding part, and then the output is result.json. So we are putting the output in the JSON format. So now JSON is there and encoding is there. So this is definitely an improvement, but there is still something more we can do to dial the security up to 11. So in the security area, there is always a scope to do something more. You can't make 100% system secure. So one other useful response header supported by all the browsers, with the exception of Mozilla Firefox, is X content type options, no sniff. So there is already some header defined by some browser which you can put in your API to mitigate that vulnerability again. So we can see this quickly. This security header was introduced by Internet Explorer to prevent browsers from MIME snipping a response away from the declared content type. Another security header is XSS protection, which automatically enables the XSS filter built into most recent web browsers. So let's see how we can put this header in our API call. to, yeah, again mitigate that vulnerability. So again here let's check the code. So yeah, the same thing, app.get hello world, then we have the get access token, the function request result, and then we have the if the condition logic that request dot access token, and then we are just putting that result dot, we're just setting the header, result dot set header, x content type option no sniff, and another one is x access protection mode equal to block. So again we are just setting this two header, and then the same logic we are putting like for the encoding part and the JSON part for the invalid language. So we are putting the result in the JSON format, and for the invalid language we are just encoding that output, right? So now how the response will look for this? So it's just giving you the 200 OK, X powered by Express, X content type option. The both the headers came, and the content type application JSON, the content type length, and dead. And then you have the like output in the same format, like for the if it is a language as English, let's say you have the hello world in the JSON. If it is an invalid language, as you can see here in this case, so the greeting will be like error in the JSON only, greeting as an error in invalid language, and then you have the encoding form of the whatever the language a user has or the attacker just try in that URI fragment. Sorry, not in the URI, right? The how when it's calling building that URI with the like curl command, maybe I can say, right? So we have the encoding, we have the JSON also in this case, and we have the header. We have set the header to make more secure. So always there is a scope to add more and more to make the system more secure. So some room for improvements here, and it is called the content security policy. This is yet another response header, okay, that quitting the specification helps you reduce the access risk on modern browser by declaring with dynamic resources are allowed to load via HTTP header. So at the last, like a resource server, let's say a resource server can do one final thing. So in all these cases, you can see why all these things are coming, because somewhere you have implemented some bad practice, right? That is not a good practice, and that's why this vulnerability, there is scope to vulnerability can introduce in your system. So you need to stop there only. Then we are not supposed to discuss all this, but we need to understand. So while building the solution, we have in our mind, right? If I do this way, there is a scope of vulnerability, but if I do in this way, there is no scope of vulnerability, correct? So that's why we need to read this and understand. Otherwise, yeah, in practical solution in real time, people are not designing the solution or system in that way, what we are trying, right? So let's see, by this line you understand. So resource server can do one final thing to eliminate any chance that a particular endpoint is susceptible to accesses. Choose not to support the access token being passed as a request parameter. So this is one line for this all like session. This is a long session, right? But for this complete session, whatever slide we discussed, a single line can just complete the entire session. That not to support the access token being passed as a request parameter. So we know there are two ways to you call the API. One is just in the URL itself, we can just pass the access token, as we have seen in the query parameter, or we can pass the access token as an authorization header. We have both the way, but we know by passing the URI parameter there is a risk. We already discussed about the token leakage and everything, right? There is a possibility of attacks when you're just passing the access token as a query parameter, or as a request parameter. So doing so would make an XSS on the endpoint theoretically possible but not exploitable, because there is no way an attacker can forge a URI that also contains the access token. This might sound too restrictive, and there might be a valid case in which the request parameter is the only possible solution in a particular situation. However, all such cases should be treated as exception and approached with proper caution. So the one liner is, if you are going to use the API, please pass the token as in the authorization header form, not as a like request parameter. Don't pass this like this, okay? And yeah, we can just definitely output that whatever we have seen, right? We can output the result in the JSON form, and just in the encoding just we can get the output of the error in the encoding, and also we can just get the output of the result in the JSON form. So by doing this, and we can add already we discussed like couple of headers we can add to make the system more secure. Yeah, so this is about the session. This is a long session, but yeah, there are a few things which we understand here, like how we can just get the output of the error and maybe the result, right? And what headers we can add, what is the best practice to pass the access token when calling some API, and how to test this like in your JavaScript app. You can test it by your own also. This is what we discuss in this session. I hope you understand, and if you have any questions, please put in the comment section. and we can just jump to another session where we'll discuss on token replay. That is the last session of this protected resource vulnerability, and then we can jump to the other vulnerability section. Yeah, thank you.